Hello friends, welcome to your own channel on artificial intelligence and machine learning. In this session, we will discuss about bias and variance trade-off. Let us first understand the concept of bias and variance. I'm sure you would have come across this image very often when the concept of bias or variance has to be explained. So in the first image, what you can see that the red shots are scattered all around the target, yellow colored target that we have here. When the data point is scattered all around the expected value, that is called dispersion, scatter. And more the scatter, more is the variance. In this case, we have low bias, high variance. Bias is low because the data points are scattered equally, almost equally on all sides of the target value. In the second image, you can see the data points are scattered and they are on one side of the expected value or the target. Now, when the data points are off on one particular direction, we say it is bias. So in this scenario, we have high bias, low variance. And in the third image, you can see the data points are scattered on one side and the scatter is also high. At the same time, the data points are off in one particular direction. This is an example of high bias, high variance. And in the last image, the data points are very close to the expected value. The dispersion is less and they are scattered all around the target. This is an example of low bias and low variance. Now, when we build a model, for example, in the image shown below, we are building a linear regression of income versus expense. We are trying to predict expense as a function of monthly household income. The blue line, the dotted blue line, is your regression line. The gray colored dots, these are your actual data points. The blue colored line is showing the predicted value. The difference between the actual and the predicted is an error. Now, whenever we build a model, we are likely to have an error. An error can be broken into three components: bias error, variance error, and noise. Noise cannot be predicted, noise cannot be eliminated. However, we can reduce the bias error or the variance error. Let us now focus on variance error. What is variance error? Now, in this simple linear regression, this predicted line of best fit, if I change a few data points here or there, for example, if this data point is not there, this is not there, this is not there, this data point is not there, a few data points have been changed and a few new data points are introduced. In that case, it is very likely that the line of best fit may become something like this. So basically the point is the line of best fit or the model is susceptible to small changes, small fluctuations in your training data set. And the error that gets introduced because of these small fluctuations which are likely in the training data set, that is called variance error. Let us now try to understand the bias error. Once again, the example I'm taking of a linear regression where I have monthly household income and monthly household expense. Now in this you can see you have two colored data points, one are in blue and the other one is in orange. So assume the blue colored data points are for salaried people, the orange colored data points are for self-employed. Now if you build a linear regression where you try to predict expense as a function of income without taking into consideration the occupation, whether the person is salaried or self-employed, in that case, the line of best fit, the model will try to fit a regression, which is something like this. Now, in this scenario, you can see that the model does not do a good job either for the salaried segment and neither it does a good job for the self-employed segment. So the model is actually under-predicting for the salaried segment and it is over-predicting for the self-employed segment. A bias error gets introduced when a predictor variable which can influence the prediction of the target variable is not present in the model. You can easily understand that this error can be reduced if we build expense as a function of income plus occupation, that is salaried or self-employed, given that we have two categories here. And if you build this equation, then automatically the equation will adjust such that the prediction for salaried and self-employed segment will be better, more accurate. More accurate means there is a reduction in error. And this reduction in error is happening by introducing a variable which has influence. And this kind of error, which is left in the model when you do not consider predictor variables having influence on the target, not being part of the equation, you get an error which is called bias error. Now it is said that as we try to increase the number of variables, or in other words, as we increase the complexity of the model, the susceptibility of the model to small changes, to small fluctuations in the training dataset increases, which means the variance error is likely to increase. Once again, as we try to make our model more complex, as we try to bring more predictor variable, the susceptibility of the model to small changes in the training dataset increases. As a result, variance error is likely to increase. On other hand, because we are bringing variables which have good predictive power, the bias error is reduced. As such, we have to build a model which is a trade-off between bias and variance. Graphically, this is quite often represented as you increase the model complexity, the bias error will keep going down. As you increase the model complexity, the variance error will go up. Total error is equal to bias plus variance. Noise is something which we cannot do anything about. So total error is summation of bias and variance. The point where our error, total error, is minimized, that is the optimal point for the model. And this is called bias variance trade-off. If you do not have a model which is optimal, in that case, you will be ending up building a model which will be an underfit, or you will end up building a model which will be overfit. In our next session, I will show you underfitting and overfitting and how we derive the optimal model. So kindly see the next video, which is on the continuation of bias variance trade-off and how we build an optimal model. Thank you.